Wow, we are here once again to continue with our business on Physics Meal. Welcome to Physics Meal. Today on Physics Meal, we'll be looking at the second part of the concept of measurement, and we'll be looking at the concept of dimensions and units. Subscribe to our YouTube channel if you have not done that, and make sure you follow us on Facebook at Mathematics and Science Meal. All right, without taking much time, let's begin the business of the day, which is on dimensions and units. In our last video, we looked at the concept of quantity, and we defined quantity. A quantity is any physical constant or variable that can be measured. And you remember we said that we have two types of quantities as far as the concept of measurement is concerned. We have fundamental quantities and we have derived quantities. We also gave examples of fundamental quantities. We say we have 7 of them that are fundamental, talking about mass, length, time, temperature, electric current, amount of substance, and then luminous intensity. Then we also say that the rest of the quantities that are not among these 7 fundamental quantities, they are all derived quantities. Okay, so let's look at the concept of dimension today, and then the concept of units. So we have dimensions. So we say that. What do we mean by dimensions? Dimensions are used to establish relationship between the fundamental quantities and derived quantities. So when we want to show the relationship between fundamental quantities and derived quantities, we are going to use what? Dimension. Soon we are going to see the various dimensions. Just cool down. But just know that we use dimension to show relationship or to establish relationship between fundamental quantities and what? Derived quantities. So the next we look at units. Look at units. Units are used to distinguish two or more quantities. So when we want to establish a difference between 2 or more quantities, we use what we call what? Units. So units are used to distinguish what? Quantities. Yes, units are used to distinguish quantities. For example, let's go further on this. If I start shouting 100, 100, 100, 100. So one is shouting 100, and you looked at somebody, the person said 100. You say 100 what? The person say 100. You say 100 what? Now the person say I'm talking about 100. So you don't know the 100 the person is talking about. You will continue to ask the person 100 what? And if the person persists on shouting 100, you may think that the person has some issues on his upstairs. Yeah, maybe the person is now mad. Yeah. So because shouting 100, 100, 100 it doesn't make any sense. There is no difference between these 4 hundreds that we just wrote on the board. So when you shout hundreds, 100, 100, somebody must ask you 100 what? What do you mean by 100? The person say 100. Say, what do you mean by 100? You're not making sense at all. The person say 100. And if the person continues to say 100, just look for your way, because maybe the person is now becoming insane. So you need to run for your life. So when we have these quantities, we don't know the difference between them until you introduce what? A unit. So if I decide to put this, we recognize this, we know this, we also know this. I think the other one have double strokes on it, and then I put X here and I put kg here. Oh, these things are now making sense. Now when you say $100, someone will know that you are talking about money. 100 naira, somebody will know you are talking about money also. So 100 naira, $100. someone will know you are talking about money. But when you are busy shouting 100, 100, it doesn't make sense. So 100 seconds, this X stands for seconds. Somebody will know you are referring to what? Time, time, time. And then 100 kilograms, somebody will know you are talking about mass. I know you may not know these two for now, but when we now look at the table of the dimensions and units of fundamental quantities, you will know that the unit of time is seconds and the unit of mass is kilogram. So you are conversant with these ones, yes, I know. Many of us, many people are conversant with anything that has to do with money. Yes, very, very, everybody. So by adding these factors here, these factors, that's what we mean by what? The units. So we have used these factors that we added to these numbers to show the difference among these words, among these numbers. So this is different from this. This 100 is different from this. If I write this 100 and write this 100, there is no difference. But this 100 now is different from this 100 because of the unit. This 100 is talking about time. This 100 is talking about mass, kilogram. This 100 is talking about money. This one is talking about time. How do we know? Because of what? Of the units that we placed there. But when you write 100 and you write 100, we don't know what they are talking about, so you cannot establish any difference between these two hundreds. Okay, so I believe the concept of units is clear. Now, the units of fundamental quantities are called fundamental units, while the units of derived quantities are called derived units. So the units of fundamental quantities are called fundamental units, while the units of derived quantities are known as derived units. So the units of fundamental quantities are called fundamental what? Units, while the units of derived quantities are known as what? Derived what? Derived units. Now it's important to also note that all the units are based on what? XI unit, the global recognized system of what? Unit. So every unit will be used in is based on XI unit, the XI unit. So all the units, so let's note that all the units are based on the XI unit. So we use the SI unit system in writing the units of this word, of these quantities. That's what we'll be using. So when we give the table of units, we are going to see the SI unit of the fundamental quantities. Remember, the units and the dimensions of the fundamental quantities are used in obtaining the units and dimensions of the word of the derived quantities. So you now see that once you know the units and dimensions of the fundamental quantities, then you can easily obtain the units and dimensions of the derived quantities. But before we look at that table, it's important to note that not all quantities have dimension. Not all the quantities we have what? Dimension, yes, and not all the quantities we have units. So a quantity without a unit is called what? A dimensionless what? Quantity. So quantities without units are called what? Dimensionless quantity. In the course of studying physics, you will discover we have so many of such quantities. So quantities without units are called dimensionless quantities. They are dimensionless quantities. And these dimensionless quantities are also they are derived quantities anyway, because they depend on the word, on the fundamental quantities. But at the end of the day, they will not have dimension. Because if a quantity is dimensionless, it has no unit, and there's no way a quantity we not have units, then have dimension. So any quantity without unit will also be without what? Dimension. So if a quantity has no unit, that quantity will not also have what? Will not also have dimension. Example of dimensionless quantity. Examples of dimensionless quantities. I'll just give three. We have relative density. We have mechanical advantage of a machine. And we have velocity ratio of a machine. There are others. Something like a tensile strain is also dimensionless. Yes, it's dimensionless. In advanced form, you will be meeting a lot of quantities like that. Those that will go into engineering, you will meet a lot of quantities like the Nusselt number, the Reynolds number. Don't mind me. Let's not go there for now. So that's on units. Now the table below gives the dimension. The table below gives the dimensions and units of the fundamental quantities. So let's see the dimensions and units of fundamental quantities. So we have fundamental quantities. So we talk about their dimensions, and then we talk about their units. Okay? So let's see the dimensions and the units of fundamental quantity. The first one is mass. What's the dimension of mass? It's capital M. The unit is kilogram, which is written as kg in short form. Then 2, we have length. The dimension is capital L, and the SI unit is meter, which is small m. The next is time. The dimension is capital T, and the SI unit is seconds, which is that. Now you remember that is second. Now remember that time can also be in minutes. Time can be in hours. It can be in days. But the SI unit of time is second. So then we have number 4, temperature. We use theta for it. If you go to some books, they will use small t. And the SI unit of temperature is Kelvin, which is K. Then 5, we have electric current. We're going to use I for it. I. This I for it. And the SI unit is ampere. Capital A. Then 6 is what we call amount of substance. In chemistry, we use this a lot. The dimension is small m, and the unit is what? Mole. So we'll be using the short form as that. Then we have the luminous intensity. Luminous intensity, we use a sort of Greek letter phi for it. And then the SI unit is what we call candela. All right. These are the dimensions of the world of the fundamental quantity together with their unit. Please, this and this are very, very important for our part 3 in the concept of measurement. Very important, because we'll be using this and this to derive the dimensions and the word and the units of the world's derived quantities. Thank you for following us till now. I believe that at the end of this video already you know the meaning of dimensions, you know what we mean by units. You have also known that the units of fundamental quantities are called fundamental units, and the units of derived quantities are known as what? Derived units. We also established that when a quantity is without a unit, that quantity is said to be what? Dimensionless. We gave examples of such quantities. Quantities like mechanical advantage, velocity ratio, tensile strain, and the rest of them. Then we also gave a table for the dimensions and the what? And the units of the fundamental quantities. Now, one thing is very, very important. Why are we looking at the table of the dimensions and the what? Units of the fundamental quantities? Without this table, we cannot get other what? Dimensions. Remember, we define fundamental quantities as quantities that do not depend on other quantities for their what? Dimension. If you look at all these quantities, they do not depend on any quantity in order to obtain their what? Dimension. So they have their own fixed dimension. So we are going to use these fixed dimensions of the fundamental quantities to obtain the what? The dimensions of the derived quantities. But that will be in our next video. Thank you for following us till this point. I still remember your tutor, Engineer Ike Okechukwu, still remains my name. Thank you and God bless you.